Explain that part to me, because I was reading about how cancer cells try and evade death.
Yeah. The best way to think about this, I think, is as a social collective, right? Every cell in this organism cares about the same thing, which is preserving the life and the health of the whole being, right? So every cell in this body is in a social contract with every other cell, right? A cancer cell basically gets out of this agreement and says, no, I'm going to fare for myself. I'm going to take all the energy I can, and I'm going to make more of myself, and it goes into, bacterial mode. That happens sometimes because of mutations, and it seems like there are other causes of this. Like, for example, hyperglycemia.
What's that? High
blood glucose, right? Diabetes is a major risk factor for developing cancer. Why is that? I don't think there are good explanations out there based on like the molecular framework of disease and, the genetic mutation perspective. If you look at cancer from an energetic perspective, and it's, I think, likely that the increase in blood glucose increases the pressure, right? There's more electrons that are being pushed onto those cells, to those mitochondria. And when you push too much energy on a system that doesn't need energy, it's like you're trying to shove, a lot of water through a very small pipe.
Something goes wrong.
Yeah, something goes wrong. Something can break. So the resistance is, if you push a lot of energy into a very small, container, or into a channel that can support that, then what happens kind of physically is an increase in the resistance to the flow. And then that can lead to the cell trying to protect itself. That's what insulin resistance is in diabetes, right? Insulin resistance is a protection mechanism. There's too much glucose being pushed onto the cell, right? And so that causes this excess, energy coming in. The cell says, too much, and it damages the mitochondria, this excess resistance, because there's too much heat produced, reactive oxygen species, oxidative stress.
I was thinking about smoking, and how smoking also is carcinogenic, it's cancer-causing.
Yeah.
And through the lens of the mitochondria, how could something like smoking be cancer-causing?
Yeah. It's clear that in cigarette smoke, there are carcinogens. There are molecules that can damage the genome and cause mutations. There's a strong link between lung cancer and smoking, but for all of the other cancers, there's much less of a clear connection between exposure and cancer. Right, the cancers that affect and kill most people, we don't really know, why they come, when they come, and it's clear that there's kind of a long history. And the science behind connecting metabolism and cancer shows that obesity and high blood glucose and diabetes, especially, which causes very high excursion, very high spikes in blood glucose, those things are damaging to our cells. And what the energy resistance principle says is that biology processes energy in terms of resistance. And it makes that kind of computation. How much energy is flowing now? And then how much energy demand and how much energy pressure am I exposed to? And if there's an imbalance, then that causes damage.
Rather than being innocent bystanders, mitochondria are hijacked by cancer. The tumor reprograms them to stop acting like the body's protective energy factories and starts using them as a manufacturing plant to build more cancer cells. Because of this, targeting mitochondrial metabolism has become a major promising frontier in developing new cancer therapies. It hijacks the mitochondria and uses them to produce more cancer cells.
So a normal cell is driven, its behavior, it's driven by the mitochondria. It's like mitochondria are in the driver's seat, right? Mitochondria can basically call the shots. Is the cell to live and divide, right? Or is the cell to contract and remain this kind of cell? Or if it's a stem cell, is it to divide or remain a stem cell? Or is it to die? Right? And cells have to make these decisions all the time. And cell suicide for the greater good is something that happens all the time in our bodies. And that's why and how we get rid of most cancer cells, right? As far as we understand, you have a cell that kind of defects from the social collective, and then the organism has the wisdom to say, okay, this is no longer ours, let's get rid of it, right? Because it could become cancer. And most of the time that works well. But what cancer cells can do is say, okay, they ditch their mitochondria, and then they start to use them for their own growth. And by ditching their mitochondria, they basically immunize themselves against the death that mitochondria could trigger. So mitochondria have a veto on cell life or death, and cancer somehow is able to kind of get away from that.